In this video, we're going to model a complete kitchen from scratch. We'll move step by step, building everything together and going through the entire process from start to finish. So make sure to stay with me until the end and don't miss this one. Hi, I'm Hussein. Welcome to another project-based tutorial on the channel. In this video, we're going to model a kitchen. If you remember, I previously shared a kitchen tutorial that was mainly designed for beginners, a simple exercise for a first experience in modeling an interior space. That kitchen was intentionally minimal and modern, so it had less complexity and allowed us to focus on the fundamentals. But in this episode, we're taking it a step further. This time, we'll model a dual kitchen layout, a clean kitchen, and a working kitchen, and explore it in much greater detail. Along the way, I'll explain not only the modeling process itself, but also the reasoning behind the design decisions. So you're not just learning the tools, you're also developing the mindset behind the work. If you enjoy this series of modeling and interior design videos, I'll definitely continue it and take on more diverse and challenging projects. Many of you have also asked about the renders and animations used in these videos. I'll be publishing dedicated tutorials very soon about rendering, animation, and professional project presentation, both in Rhino and in other related software. If you're interested in this type of content, make sure to subscribe so you don't miss the upcoming videos. All right, let's get started with the project. I've also marked the different sections of the video, so if you prefer, you can jump directly to the part you're looking for. Like most videos in this series, before we jump into modeling, let's take a quick look at the concept of a clean and dirty kitchen. A clean kitchen, also known as a show kitchen, is the space that's visible. It's usually open, well organized, and designed with high quality materials. This area plays more of a social and visual role. It's where you interact with guests, serve food, and maintain a clean, polished image of the space. That's why elements like seamless countertops, hidden cabinetry, built-in appliances, and controlled lighting are especially important here. On the other hand, the dirty kitchen, or back kitchen, is the functional workspace for serious cooking. This is where heavy cooking, frying, food preparation, and most of the washing happens. It's typically more enclosed, with stronger ventilation, washable surfaces, and more storage space. In terms of layout, it's usually placed behind the clean kitchen or separated by a sliding door, so smells, noise, and visual clutter can be controlled. Now that we understand the concept, let's move on to the modeling process. First, we start by setting up the project and adjusting the units to our desired scale. I'll set the unit to centimeters because for architectural modeling at this scale, it gives us better control over details and makes the numbers easier to read. If the units aren't set correctly from the beginning, we can run into scaling issues later, so take this step seriously. Like in previous videos, I've prepared a base AutoCAD file that we'll use as our starting plan. I simply drag and drop the file into the project and choose the import option to bring it into the scene. Once imported, I select the objects, create a new layer called AutoCAD, and move all the lines there to keep the project organized. Next, to clean up the scene, I run the purge command to remove any extra layers or information. This helps make the file lighter and tidier. Finally, I select all the lines and lock them so they won't move by accident while we model. This gives us a clean, controlled foundation to start building the 3D forms, and now we're ready to move into the modeling stage. First, I create a new layer called walls so that from the very beginning, all objects are organized and clean. Then, using the polyline command, I start drawing closed lines over the wall plan. Since the AutoCAD file is locked and OSNAP is active, we can snap very precisely to the baselines and establish accurate boundaries. Once the closed lines are complete, I select them and extrude them from floor to ceiling. I'm setting the floor height to 280 centimeters here, so I set the extrude value to 280 to form the wall volumes. For the window openings, we follow a logical step-by-step approach. I draw a rectangle at the window location and first extrude it up to the sill height. Then, using the gumball, I move it upward by the window height. Here I've chosen 120 centimeters. After moving it, I extrude it again through the full wall thickness to complete the cut. Finally, I select all the walls and use the Boolean union command to combine them into a single clean volume. This gives us a neat, organized shell ready for the next stage of modeling. Now we're going to create an initial mass of the kitchen, a solid box that acts like a rough guide and helps us visualize the form and proportions better. I start with the box command. I set the height of the tall cabinets to 250 centimeters, the countertop height to 90 centimeters, and the vertical gap between cabinets to 65 centimeters. These dimensions give us a clear and understandable initial volume for the cabinets. As you can see, using the locked base layer and tools like Box, Polyline, and Extrude, we build this basic form. Now we have a simple volumetric model that we can refine with more detailed and precise modeling, bringing the kitchen design to life in 3D. First, we create a new layer called Cabinet to organize all cabinet elements separately from the other objects. Next, we switch the display mode to Ghosted. This makes the volumes and underlying lines on other layers semi-transparent, so we can focus more easily on modeling the cabinets. The previous layers are locked to prevent accidental changes, keeping our workspace clean. Now, let's start modeling the cabinet base panels. Using the rectangle tool, we draw the shape of the base panels on the plan. With the gumball, we move the panels up by 13 centimeters to set the correct distance from the floor. Then we use the extrude command to give the panels a thickness of about 1 centimeter. After this, we select all the panels and use the isolate command. All the locked layers are hidden, so only these objects are visible, helping us focus on the current section. For the cabinet legs, we need guidelines to position the legs accurately. We offset the extruded base panels by 10 centimeters to mark the leg locations. Then, using the cylinder tool, we create the legs from the underside of the panel down to the floor. The leg height is 13 centimeters, and the radius can be adjusted as needed. We place the cylinders precisely on the guidelines and use the copy tool to duplicate them across all required positions, keeping the legs aligned and organized. Next, we model the kickboard, the panel that covers the area under the cabinets. Using Polyline, we trace the edges of the underside panels in the kitchen space. Then we offset these lines 5 centimeters inward to give a better visual effect. After creating a closed curve with a 1 centimeter spacing and enabling caps on flats, we extrude it to a height of 13 centimeters, connecting it to the floor. We repeat this process for all cabinet sections so that every base panel and leg is fully modeled and ready for the next step. At this stage, the cabinet legs and base panels are completely formed, giving us a clean, organized structure ready for detailing. This method keeps the project tidy and makes it much easier to model additional elements like drawers, handles, and side panels in the next stages. Now we move on to modeling the inside of the cabinets, which is essentially a continuation of the previous step, but with more detail on the cabinet interiors. As you know, cabinet structures are usually made from connected panels of wood, MDF, or similar materials. So, we start with the base we built earlier. Using the polyline tool, we draw a closed profile for one of the vertical members and extrude it about 1 centimeter. These vertical members are positioned to support the horizontal panels, like the base and top shelves. At the intersections of vertical and horizontal members, we use the Boolean split command to separate overlapping parts, then select and delete any excess sections. Once each cabinet structure is complete this way, the initial base box is no longer needed and can be removed to keep the scene clean. To add more realistic detail, we want the edges of the horizontal panels, the bases, tops, and internal shelves to be recessed by about 1 centimeter. To do this, hold Ctrl and Shift, select the edges, and push them back roughly 1 centimeter using the gumball. We repeat this for all cabinets, giving the interiors a more precise and realistic look. For the countertops, we follow a similar workflow. First, we draw a closed curve with the polyline tool, then use trim and join to make a complete closed profile. Next, we extrude it to the thickness of the countertop. I chose 4 centimeters here. To make the model even more realistic, we use fillet edge with a 1 millimeter radius to round the edges, giving the countertop a natural, lifelike feel. Finally, we repeat this process for all cabinet boxes, vertical members, horizontal panels, and countertops. You can partition the interior of the cabinets based on your design preferences or project requirements, modeling them in a realistic and functional way. Now we move on to modelling the drawers in the cabinets. First, we draw a guideline along the cabinet. Using the divide command, we split this line into equal parts, for example 4 segments for 4 drawers. The points created along the line help us place the horizontal panels precisely in their correct positions. At this stage, we make sure that the vertical members extend down to the cabinet base, and the horizontal panels are pushed in about 1 centimetre to create a recessed edge, giving a more realistic feel. This process is basically the same for all drawer cabinets. To make sure you see the entire workflow and don't miss any details, I won't cut the video here, but I'll speed it up slightly so the long process isn't tedious and you can follow all the steps more comfortably. We now repeat the same modelling process we used for the clean kitchen for the dirty kitchen. The view we're creating now with the cabinets and internal panels is sufficient for this stage. It helps us understand the overall volume and organisation of the kitchen. However, when we move on to placing the stove, sink, and other appliances, We might need to adjust some dimensions or positions to make the kitchen function realistically and ensure all elements work together harmoniously. For now, our focus is on the structure and volumes, and we'll refine the functional details in the next stages. Now we move on to modelling the kitchen island and making small adjustments for user comfort. To ensure people can sit comfortably on the bar stools, the island cabinet, except for the countertop, is offset slightly inward. To do this, I hold Ctrl and Shift, select the bottom edge along with all the legs, and push them inward about 20 centimeters using the gumball. The middle legs are also moved 10 centimeters to maintain proportion and symmetry, keeping the island centered. Next, I draw the vertical members of the island. We divide the island into 5 sections. The first 4 are equal, and the one with the drawer is twice the height or length of the others. Following the workflow we used earlier, we model these sections. This helps speed up the video and avoids unnecessary repetition. At this stage, the legs and cabinet interiors are complete. Now it's time to move on to modelling the cabinet doors and creating the final details of the cabinet exteriors. Before we continue, I want to give a special thanks to all of you who have stayed with us this far in the video. I really appreciate the time you've taken to watch and learn from this tutorial. If you found this content helpful and enjoy the channel, please consider subscribing, liking the video, and sharing your thoughts in the comments. I'd also love to hear how you want this interior design series to continue. Do you want us to explore different kitchen models, work on other residential interiors, see the full design process in the videos, or just focus on modeling? Rest assured, I read all your comments, and future videos on the channel will be shaped by your feedback and suggestions. Before we start modeling the cabinet doors, I renamed the layer we previously called cabinets to cabinets_base to make it clear that this layer contains the base cabinets. Then I create a new layer called cabinets_door so that all doors and drawers are built here, keeping the project organized. First, we use polyline to draw a closed curve on the cabinets, exactly where the door will go. Then we offset the curve by 1 millimeter to create the gap between cabinets, making it look more realistic. Next, we extrude this closed curve 1 centimeter to form the initial door thickness. After that, we bring the offset inner line onto the door and offset it by 6 centimeters. This inner rectangle is extruded 5 millimeters with the both sides option enabled, so the extrusion goes both ways. This makes the Boolean difference operation easier and more precise. Then we subtract this second rectangle from the door using Boolean difference to create the internal recess. To make the edges look more realistic, we use the chamfer edge command with a 5 millimeter value on the outer door edges, which highlights the internal recess nicely. For the cabinet handles, I use ready-made objects. I copy and paste them into the project and place them in the correct position using Gumball. We repeat the same process for all other doors and drawers. Since many of you like to see the full workflow, I won't cut the video, but I speed it up slightly so it's not too long or tedious. All the objects used in this video, following the approach from previous tutorials, are available in the description. Additionally, you can download and use objects from various sites to make your modeling more personalized and diverse. Similarly, I use the same method to model the island cabinet doors. At this point, the main structure of the kitchen is forming, with the cabinets and island volumes finalized. Next, I'll focus on adding finer details and objects to make the kitchen feel more realistic and complete. We start by placing the window in its correct position. Using Ctrl-C and Ctrl-V, I paste the objects into the project and position them precisely. As I mentioned earlier, all the models and objects I use have download links in the description, so you can easily download and use them in your own projects. I do the same for the refrigerator. Since the space above the fridge is usually empty, I model the upper section of the fridge following the same workflow we used for the cabinets. This keeps the kitchen cohesive and well organized, ensuring that all details are placed neatly and accurately in their intended positions. Now we move on to modeling the sink. You can use any ready-made sink models, but I want a rustic sink, so I decided to model it myself. Fortunately, it's not too complicated. First, using polyline, I draw a closed outline of the sink on the countertop and raise it about 1 centimeter for better and more precise placement. Then, I extrude it downward by 20 centimeters to form the sink volume. As you can see, because the sink intersects with the cabinet doors, we first isolate them and lock the countertop and sink to keep the workspace organized. Then, holding Ctrl and Shift, we select the top edges of the doors and handles and move them downward with gumball, placing them just under the sink. To fill the empty space between the doors and the sink, we create a panel 1 centimeter thick and use Boolean split to subtract it from the main volume around the sink. This way, all elements are integrated and accurately positioned. Now we move on to the detailed modeling of the sink, which is a key part of the kitchen and adds a lot to the realism of the model. First, holding Ctrl and Shift, I select and delete the solid panel we previously drew for the sink. This clears the workspace and allows us to create the new sink volume without any interference. To give the sink a realistic thickness and depth, we use the offset surface command. We offset the sink surface inward by 1 centimeter to simulate the wall thickness. If the offset goes in the wrong direction, simply enable Flip All to correct it. These small details make a big difference, ensuring the sink looks natural when light and shadows interact with its surfaces. After creating the main body of the sink, we add the faucet. I use a ready-made object, copy and paste it into the project, and place it precisely with gumball. I also adjust its scale slightly to match the sink we modelled, keeping the proportions correct. This makes the sink realistic not only in volume but also in functional details, ready to be placed in the final scene. We follow the same workflow for the clean kitchen sink on the island. First, we draw and give thickness to the main body, then place the faucet in its proper position, adjusting sizes and scales as needed. This ensures that all sinks in the kitchen are cohesive and harmonized. With this approach, both the overall kitchen volume and functional details, like sinks and faucets, are fully modelled and ready for the next stage. Now we move on to the next stage, placing the oven and related components. I bring the oven into the project like the other objects and position it in its proper spot. When I check the size and placement, I notice that one of the cabinets is slightly too large, so I adjust its interior design to match the oven size and ensure all elements fit correctly. As you can see, I also added 2 vertical drawers next to the oven, which are functional and provide extra storage space. The modelling workflow for these drawers is the same as before, so there's no unnecessary repetition since we've done this multiple times already. Additionally, there's a sliding door between the clean and dirty kitchens, which is a simple panel. I model this door and place it in position to simulate realistic access between the 2 kitchen areas. With this step, the overall kitchen volume becomes more complete and coordinated, and we're ready to move on to the next stage: final details and small props. Now we move on to placing the cooktop and the hood. I bring the cooktop into the project like the other objects and position it in its proper spot. As I mentioned earlier, the cabinets can still be adjusted so we can modify sizes and placements as needed. At this stage, we notice that the space for the hood above the cooktop wasn't accounted for in the cabinets. So I remodel the upper cabinets to create enough room for the hood. Then I place the 3D model of the hood in its correct position, just like the other objects. At this point, almost everything is in place, and only the final touches and cleanup remain. For example, in the clean kitchen sink, one of the vertical members inside the island interferes with the sink. I use Boolean split to separate and remove it, creating a clean and unified interior space. And that's it. Together, we've modelled a complete dual kitchen, from cabinets and drawers to sinks, oven, cooktop, hood, and small details. Everything is built step by step, neatly organised and ready for rendering or use in your project. Alright, before we wrap up today's video, let's have a quick recap. In this tutorial, we modelled a complete dual kitchen, from the cabinets and island to the sinks, oven, cooktop, hood, and small details like handles and doors. While modelling, we also went over key interior design principles and layout tips, making sure the model is both realistic and functionally organised. This video showed step by step how to start from a base AutoCAD file, build walls, cabinets, and interior members, and then add objects and details to create a fully complete 3D model ready for rendering. If you enjoyed this tutorial and found it helpful, please like the video, subscribe to the channel, and turn on the notification bell so you don't miss any future videos. Your support motivates me to create high-quality educational content and makes future videos even better and more complete. Your feedback is very important to me. Please leave a comment letting me know how you like this video and what topics you'd like to see in future tutorials. Do you want more focus on modeling, or would you like to see the interior design process and project details as well? Rest assured, I read all comments, and future videos will reflect your suggestions. Thank you for staying with me until the end, and I hope this tutorial was useful for you. I can't wait to see you in the next videos. And don't forget, subscribe, like, and share your thoughts in the comments.